In this concept, we're going to talk about laws of exponents, okay? And exponents are very important. We did introduce them in a prior concept, and here we're going to expand on their laws. And these are very important to understand as opposed to just memorize mindlessly, because when you understand them, you'll be able to recognize the patterns when they show up in problems, and that will help you solve such problems at a faster pace, okay, which is obviously very useful for the test. Let's look at the first law here. So a product of powers. And what this means is when I multiply two terms that have exponents, right? So two powers. So remember, a power is the base and exponent, right? So in this case, if I had a to the m power, or to the m exponent, times a to the n power. The result of this operation, right, given that the bases are the same, the bases, right, the base here being a and a, right, so it's the same base, but even if the exponents are different, all you do is you just add the exponents, right? So you write the base once, right? So here you add two of it, but here you write it once, the base, and then you just add the exponents. But the base has to be not equal to 0, okay? It cannot be equal to 0. If it were 0, well, this would be sort of an illegal operation, okay? So the base has to be any number besides 0. So again, all you would need to do is add the exponents. So when the base is the same, add the exponents. Let's look at examples. 5 to the 5th power times 5 to the 8th power. So the base is the same, 5 and 5. Right? So what is the result? So you take the base, write it as a common base, right? And then just add the 5 and 8. So it's 5 to the power of 5 plus 8, which is the same as to the power 13. Right? So 5 to the power 13. And obviously, this comes out to a rather large number. You can use the calculator to evaluate it, but we'll stop at it at this point. Here's another example. So x to the 4th times x to the 10th times x to the minus 3. So the base here is x, right? Common base. So you take it again in the result. And then just add these powers, these exponents. 4 plus 10 plus negative 3. So 4 plus 10 minus 3, which comes out to x to the 11th. Okay? Very straightforward. But this rule applies as long as the bases are the same. Keep that in mind. Okay? Quotient of powers. Very similar to the product of powers, but here you have division, right? So you have a quotient in the end. But again, as long as the bases are the same, you would subtract the exponents, right? So here you have a to the m minus n power. And again, as long as a is not equal to 0. So if a were equal to 0, this would not be valid. Okay, so it's a to the m minus n power. So when dividing powers with the same base, subtract the exponents. Let's look at examples. X to the 4th divided by x to the 3rd. So again, common base x. So just take the exponent up here, 4, and then do minus 3. Do 4 minus 3. So x to the 4 minus 3 power, which this comes out to 1. So x to the 1, x to the first power, which is just x. Okay, x to the 10th divided by x to the 3rd. Again, very similar to number 1. Very straightforward. So x is a common base here and here. So we take the base and we rewrite it here in the result, and then just take the exponents, 10 and 3, so 10 minus 3, right? So then we get x to the 7th power. So obviously, if it were not clear by this point, you subtract the first, you subtract the second from the first, right? The second exponent from the first. So it's the first minus the second. Here's another example. 2 to the 5th power divided by 2 to the 2nd power. So you can see that in examples 1 and 2 we were writing the division as fractions, but the same thing applies if we just write the division sign, okay, as opposed to writing these as a fraction. So again, common base 2 and 2, and then the exponent is 5 and 2, so we write the base 2, and then we just subtract we do the first exponent minus the second exponent. Right, so 5 minus 2 is 3, so 2 to the 3rd is 8. Okay, the next law is the law of negative exponents. And the goal is to really learn what to do with negative exponents, right? What do they mean for your expression? So let's say you had something like a to the minus n, where a, again, is not equal to 0. The base cannot be equal to 0. So a to the minus n is the same as 1 over a to the n plus n, right? This could be plus, this is plus n. Right? And what does this mean? So when the exponent of a certain power is negative, take the reciprocal of the base while keeping that same exponent, of course. Right? So just flip the base over. If it were in the numerator, like here, or just like a standalone number, which is the equivalent of it being in the numerator, right? Because this is the same as a to the minus n over 1, right? So taking the reciprocal means just flipping it over, right? So the 1 comes on top, the denominator comes on top, which is 1, and then the numerator, which is this expression, goes down, right? So you get 1 divided by a to the n. This is what a negative exponent does to an expression. Let's look at some examples. X to the minus 2. So again, just flip it over. This is the same as x to the minus 2 over 1. So again, just take the reciprocal, right? So that becomes 1 over x squared, right? So you take the reciprocal of the base with the you could say the absolute value of the negative exponent, right? If it were negative, so you just make it positive, but then having flipped it means you got rid of the negative sign. Okay, 5x to the minus 10th power. So only the variable has the negative exponent. In fact, only the variable has just the exponent to begin with, as well as the negative sign with the exponent, right? Meaning this minus 10 is applied just to the x, not to the 5. So the 5 stays as is in the numerator, right? So again, this is the same as 5x. Let me just move this. This is the same as 5x to the minus 10 over 1, right? This is a1. So the 5 stays in the numerator, and then we take the x to the minus 10 and bring it down to the denominator, but we get rid of the negative sign, right, when we bring it down. So we bring it down as x to the 10th, right? So this is 5 over x to the 10th. But this is interesting. Let's look at another instance of this, well, not another instance, just another case that would have looked similar to this. So this is 5x to the minus 10. The minus 10 again, is applied to the x. What if you had something like this? What if you had, in parentheses, 5x, the whole thing to the minus 10, right? Well, in this case, the minus 10 would be applied to both the 5 and the x, and we're going to get to that soon, right? So this would be equal to 5 to the minus 10 times x to the minus 10, right? We'll get to that actually in an upcoming property. But just keep this in mind, right? To be able to differentiate which terms the exponent applies to. Another example: 2 to the minus 5. Again, just flip it over, bring it down. So 1 over 2 to the 5, which is 1 over 32. Okay, next law: power of a power. So we have a power inside the parentheses, and then we take the power of that whole thing inside the parentheses. Right? So a to the m, the whole thing to the nth power. And in this case, we multiply the two powers. Okay, we multiply. We multiply m and n. Right? So you get a to the m times n power. And again, a cannot be equal to 0. So when finding the power of a power, multiply the exponents. Let's look at examples. So x squared all to the third. Right? So multiply the 2 and 3. So you get x squared to the 2 times 3, which is x to the 2 times 3, which is equal to x to the 6th, right? Because 2 times 3 gives you 6. 3 to the 5th, all to the third power. So again, multiply the exponents and then take the base the same. So 3 and then 3. So then 5 times 3 becomes the new exponent, which is 15. So it's 3 to the 15th. 2 to the 4th, all to the minus 2. Again, you can just multiply the exponents directly and take the base as common, right? So here's the base, and then 4 times negative 2, which is negative 8. Of course, we can simplify this further, using the law of negative exponents, right? And just to remind you of it here, again, the goal in a negative exponent is to take the reciprocal of the expression. Okay, take the reciprocal of the base while keeping the exponent the same. Taking the absolute value, I should say, of the exponent. So 2 to the minus 8 is equal to 1 over 2 to the 8. Okay, next law, power of a product property. And this is something that I brought up a couple of examples ago. So again, if you had two items, right, like two numbers or two variables, whatever, and then they're both multiplied, say, in parentheses, and then the whole parentheses is raised to some power, right, number or symbol, like m in this case, but m here represents a number. What happens is this, again, gets distributed to each of the items in the term. Okay, so you'll have a to the m power, and then times b to the m power, where again, a or b should not be equal to 0. So when finding the power of a power, multiply exponents. Okay, let's look at some examples of this law. So power of a product. So we have a product, x squared, and y cubed, right? This is a product, x squared times y cubed. So the whole thing is raised to the third power. So what do? We distribute this exponent to the x squared and the y cubed by multiplying it with these existing exponents. So this gets multiplied by this 2, and this 3 gets multiplied by this 3. So we have x to the 2 times 3, and then we have y to the 3 times 3, which in this case is 6, and in this case is 9. So we have x to the 6th times y to the 9th. Okay? 1/2 x to the 5th times y squared, all parentheses, all raised to the second power. Okay. This one is a little packed up, so let's try to unpack it. So the second power, again, distributes to all the different items in the parentheses, right? So it distributes to the 1/2, so you get 1/2 squared. And then the 2 distributes to the x to the 5th, so it becomes x to the 5 times 2, right? And then it also distributes to the x to the 2nd, and then it becomes x to the 2 times 2, y, so it distributes to the y to the 2nd, so y to the 2 times 2, right? So 1/2 squared, or 1/2 to this, all to the second power, and then x to the 5 times 2 power, and then y to the 2 times 2 power. So 5 times 2 here is 10, and 2 times 2 here is 4. So it's 1/2 all to the second power, so you square the top, you square the bottom, right? Again, you would distribute to both of these. So 1 squared is 1, right? And then 2 squared is 4, right? So this expression is the 1/2 squared. Okay, and then we have the x to the 5 times 2, which is 10, so x to the 10th, right? And then we have the y to the 2 times 2, which is y to the 4th. So this is the final answer. Here's another example. So x, y, all to the 4th power. So again, the 4 distributes to both items in the term, which are x and y. So you have x to the 4th, and then y to the 4th. And they're multiplied. Right? A 0 exponent. And this one is very straightforward. Any number, variable, or expression, right? So a number, a variable, an expression, anything. Anything except 0. Okay? When raised to the power of 0 is always equal to 1. Right? So always equal to 1. Except 0. So 0 to the 0 is an illegal operation. Okay, it is an irrelevant operation. Anything else to the power of 0, 3 to the power of 0 is 1. 6 to the power of 0 is 1. Pi to the power of 0 is 1, etc., etc. Let's look at some examples. A to the power of 0. Again, assuming A is any constant, right? A to the power of 0 is 1. 2 times x, all raised to the power of 0, is 1. Whatever x is, even if it's a variable, right? We don't know its value, it's a variable, yet still, whatever it comes out to be, when raised to the power of 0, you get 1 in the end, right? So here, even if you distribute the 0 to the 2 and to the x, you would have something like 2 to the 0 and then x to the 0, right? Which is still 1 times 1, which is 1. Okay? 100 to the 0th power, again, this is 1. 4x plus y in parentheses all to the 0th power, again, is 1, even if x and y are variables. Let's look at some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so let's look at these. So we have 2 to the 0th power plus x to the 0 plus x, y, z all to the 0. This is pretty straightforward. Okay, even if you have different types of terms here, so you have constant, you have a variable, and then you have a bunch of variables multiplied together, they're all raised to the power of 0. So each one of them is going to be equal to 1. So 2 to the 0 is going to be equal to 1, right? And then plus, and then x to the 0 is going to be equal to 1, plus, and then x, y, z all to the 0 is going to be equal to 1. So I have 1 plus 1 plus 1, which gives me 3. So the answer is 3. Okay? 5 to the minus 1 over y to the minus 1. Remember the talk about reciprocals, right? So what does a negative power do? It tells you to take the reciprocal. Or I'm sorry, a negative exponent, it tells you to take the reciprocal of the base, right? So whatever is in the numerator goes to the denominator. Whatever is in the denominator goes to the numerator, etc. So 5 to the minus 1 is essentially 5 to the 1 on the bottom, right? 5 to the plus 1 on the bottom. Right? So I flipped the base, kept the power, kept the absolute value of the power, and did away with the negative sign. Y to the minus 1 is, again, you bring it on top and you get rid of the negative sign in the exponent. So you have y to the 1, right? But we said that anything raised to the 1 is that thing itself. So this is just equal to y over 5. Okay, 2xy all to the minus 3 power plus 1 over x squared. So 2xy all to the minus 3, again, so you take the reciprocal, keep the absolute value of the power, but take the reciprocal of the whole thing. In this case, you do apply the operation of the power to all of these items in the term. The 2, the x, and the y. But we can keep them in parentheses for now, right, just to keep things simple. So this is just 1 over 2xy to the third, to the plus third, to the plus 3, okay, power, plus 1 over x squared. Well, can we simplify this any further? Well, sure we can. We can distribute the 3, right, to the 2, to the x, and to the y. So we have 1 over 2 cubed, right, times x cubed times y cubed plus 1 over x squared. Right? Of course, so 2 cubed is 8, right? This is equal to 8. And, you know, we can always simplify this further, right, by finding a common denominator and all, but, you know, this is not too important at this point. The point here is to just show you the law of the, you know, to show you some of the laws of the exponents. So you can, you know, in this case, we can keep it at this form. X to the fourth times y to the minus third divided by x to the third times y to the minus 8. Well, for this one, there's you know, quite a couple ways on how to solve this. first here we have a multiplication, right? So x cubed times y to the minus 8. So this is also the same. We can rewrite this initial part to look similar to this, right? So we can have x to the fourth. We don't need the multiplication sign. It's already assumed, right? If we put both of these items next to each other, it's assumed that they're multiplied. So x to the fourth, y to the minus third, and then divided by x to the third, y to the minus 8. Now, the simplest way to solve this is, again, just treat this as the division law, the quotient law of exponent, right? In which case we would subtract the second term from the first term for each of the like terms. Okay, and what do I mean by that? So we have x to the fourth here and x to the third here. So I'm going to apply the operation to both of these together. So I can't say x to the fourth minus y, or the fourth here in the x minus the negative 8 here in the y, because, well, the y's are going to be, the operation is going to be applied to the y's together and then to the x's together. So that gives me x to the 4 minus 3, right, because I have 4 here and then I have 3 here. So again, take the base, take the common base, and then subtract the two exponents. And then I'm going to get something for the y also, but it's still going to be multiplied by the x in this case. And I'm just going to have, so just rewrite the base, which is y, and then I have minus 3 minus negative 8. So I have minus 3 minus negative 8. Okay, because remember, this is negative 8, and we have to subtract. So it's minus 3 minus negative 8, which equals x to the 4 minus 3 is x to the 1, which is just, x, right? Times y to the minus 3 minus negative 8. So minus 3, the negative and negative, two negatives cancel and become a positive. So it's minus 3 plus 8, which is minus 3 plus 8 is 5. And this is the answer. Okay, next one. So 3xyz all to the minus 1 power divided by yz squared. So that equals, again, remember the law of negative exponents, and all it tells me to do is to take the reciprocal of the term that has a negative exponent. So the yz on the bottom remains the same, right? Doesn't change. But then the 3xyz comes down here with a power of positive 1, right? So 3xyz. And then up here, of course, we're going to have a 1, right? So here what we could do, how do we simplify this further? Well, we could, again, multiply like terms together, or like bases, I should say. Multiply the like bases, and then, and by doing that, I mean you take the common base, right? You don't multiply the base by itself, obviously. You just take one of them, and then you add the powers of the like bases. So 3x, right? Let's start, from the earlier letter to the later letter. So let's start writing from the x, and then the y, and then the z, right? And then obviously let's start with the coefficient first. So we have 3x, right? And there's nothing else to multiply the 3 or the x, so we just write 3x. And then we have 1y here, and 1y here. So y to the, this is the same as y to the first power, and y to the first power. So y to the 1 times y to the 1 is y to the 1 plus 1, right? Which is 2. And then z, here I have z squared, and then I have z to the 1, right? So that's the same as z to the 2 plus 1, which is 3. Okay, so the final result is 3xy squared z to the third. But remember, all of this is in the denominator. Okay, I made a little mistake here. So this is in the denominator, right? Right, so this is really 1 over 3xy squared z cubed. Okay, last one. So 5x over y times 25x to the fourth over y to the fifth. So this is pretty straightforward. So just multiply the numerator by the numerator and then the denominator by the denominator. And it's nice since the terms are like, right? In the numerator it's the x's, and then in the denominator it's the y's. So it's even more straightforward. So multiply the coefficients first. 5 times 25 is 125. And then x times x to the fourth is x to the 1 plus 4, right, which is 5. And then down here is y times y to the fifth, so it's y to the 1 plus 5, which is 6. So the answer is 125 x to the fifth over x to the, y to the sixth. Okay, so I hope this was straightforward enough. This is it for this concept. See you in the next video.